Hello and welcome to AnalyzerPro Shorts, the series where we show you bits and pieces of AnalyzerPro in order to help and inspire you with your daily work as a traffic accident analyst. Today we are going to have a look at a certain module that is, quite a handy one, if you ask me, for a certain type of cases. And I'm talking about the module drive off and brake. So a module a kinematics module that you usually take when you know a total distance for a certain driving and braking behavior, but actually don't know how and where the acceleration happened, where the vehicle stopped and where it reacted and so on. So let's have a look at this quite typical example here. We have this parking lot and there was maybe a low speed collision between the blue car that tried to park out here and the red car probably coming from here. So what I'm going to do now is, in the first step, I'm trying to show or to mark a path the blue car possibly could have taken. So for that I'm taking this spline curve and just marking here a rough driving line the rear could have taken. Could be the front, could be the center. Just have to measure the same things. So when I'm going over here and I mouse over, I see immediately how far that is, and that's 6.5 meters. So we can assume now that this car initially stood here, accelerated, probably, that's of course depending on the situation, saw the red one, braked, but there was still a little collision going on. In cases as such, a collision analysis per se is completely pointless because we have so small collision speeds that we can't really work with a collision analysis. And also, it doesn't really matter if we do have a collision speed of 1 km/h or 2 or 3. But we want to analyze where he possibly could have seen the red vehicle and especially how the behavior of the blue car could have looked like. So let's remember, 6.5 meters. I'm going to modules and then drive off brake. I want to do my calculation for my vehicle number 1, which is the blue one. And now I have to put in a few values. So my initial velocity is, of course, 0. Build-up time for acceleration, we usually take 0 as well. Acceleration, well, this is a parking lot, so probably he might have done it a bit slower. Let's say maybe 1.5 meters per square second, or maybe just 1. If we knew that there was some time where the blue car went with constant velocity, we could put it in here. Sometimes we might know that, but if we don't, we can just leave it for 0. Same goes for velocity limit. So do we know if the blue car just accelerated to a maximum velocity of, let's say, 10 km/h or not? Well, if we don't, we just leave it at 0. Driving direction is backward in that sense. Reaction time 1 second, build-up time 0.2. These are default values, work pretty well for me. Deceleration, so maybe let's go a bit higher because you might have seen it. So let's say 5 meters per square second. Final speed, well, of course depending on the damage images we have, but let's just give it 2 km/h or maybe 1. And the total distance, that would be again our 6.5 meters. 6.5. And I can click on calculate. I immediately get a lot of results here. So I get the position of reaction 2.42 meters before starting or 4.8 meters before ending. The same with the time, the maximum velocity reached, which is 11.6 km/h, and so on. And we also get a vehicle over here that I can now adjust. Adding another point here. doing something like this. And you can see how easy, oh, maybe I should let it go a bit at another point. So something like this. So, and you can immediately see how easy we can calculate a full driving process like this. We can now check, okay, maybe where's the reaction point? Oh, he was exactly here. Where did he start to brake? Oh, that was only shortly before the crash. And so on and so on. Of course, let me remove this one so it doesn't disturb you. Of course, we can now, or we could now, work on the movement of the red vehicle. We could draw our conclusions from that. We can also have a look at the coordinates by just then go seeing, okay, this is the acceleration speed, acceleration phase, reaction phase, and so on, and then a collision with 2 kilometers per hour. I hope you could see how easy you could work on cases like that with this module. I hope you enjoyed the video. Have a great day and bye bye.